In this video, we're going to identify conic sections by completing the square of the equation of the general form that we're given. So, in general, a conic section can have a general form that is not directly in the form of which is obvious of which type of conic section it is. The general form is when you have ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0, and a, b, c, d, e, f, these are all going to equal to real constants, and a, b, and c, they are not going to be zeros, or not all are zeros. So this equation is the general form for our parabolas, ellipses, circles, and hyperbolas, and also degenerate cases like lines and points. So specifically, I want to talk about our bxy term. This should be y. And this is going to indicate when b is not equal to 0. And when it's present, this means that the conic section is rotated. AKA the axes are not parallel to the coordinate axes. Now, we have to identify the conic. So when we are identifying the conic, you're looking when b is equal to 0. Or if there is no xy term, you're going to have b is equal to 0. Then you can identify the conic by looking at the coefficients. So by looking at the coefficients of a and c and your x squared and y squared terms, you can write these rules down. So for a circle, you're going to have that a is equal to c, and they're going to have the same sign. A and c, same signs. For your parabola, you're going to have that a is equal to 0 or that c is equal to 0, but not both. Now for an ellipse, you're going to have that a is not equal to c, but a and c are going to have the same sign. Now for hyperbola though, you're going to have that a and c have opposite signs. You can also use your discriminant, not the equation, to classify these conics. So by using your discriminant, this is when your b is not equal to 0. So we're going to use b squared is minus 4ac, which you might recognize from the quadratic formula. So for a circle, aka an ellipse that's just not having an uneven stretch, but for either a circle or an ellipse, you're going to have your value is going to be less than 0. For a parabola, this value is going to be equal to 0, and for a hyperbola, it's going to be greater than 0. Now, your general form can often be converted to a standard graphable form by grouping the x and y terms and completing the square. So we're going to complete the square, but before you complete the square, you have to group your x and y terms close to one another, and you should also isolate all constants to one side. So let's show this in action. Let's say that we have a problem like this: x squared plus y squared minus 6x plus 8y plus 9 is equal to 0. So what's our first step here? Well, what we're going to do is group our x and y terms. So this is going to be x squared minus 6x plus y squared plus 8y plus 9. And we're actually going to make a gap here for what we're about to add. is equal to 0. So now we're going to take the completion of the square for x and y. So here we have 6 and here we have 8. So we're going to have negative 6 over 2 squared is equal to 9. And we have 8 over 2 squared is equal to 16. Now you add these back to both sides, 9, and you add 16 here. And you're going to do that same thing on the other side. So here, let's subtract our 9 on both sides. And this is equal to negative 9. And you have to add that 16 and 9 to both sides. So you have your plus 9 and plus 16 here. Now after this, you're just going to factor your perfect squares. So for this, we know we can factor this as x minus 3 squared. And this can be factored as y plus 4 squared. And this, if you sum that, that's going to be 16. So what type of conic section is this? This is going to be a circle. So you're going to have a center that is 3 and negative 4, and your radius is going to equal to the root of 16, and that's going to equal to 4. So this is your circle, and if you wanted to graph this, this would be looking like this. You would have your center at 3, negative 4, so over here, and your radius would be 3, or your radius would be 4, so out there, and then you would have up here, so 1, 2, 3, 4, 1, 2, 3, 4, here, and here, and here. So can connect those points. It would look like something like this. Now let's do another problem like this. So let's say we had, for a second problem, we had 4x squared plus 9y squared minus 16x plus 36y plus 4 is equal to 0. First, we're going to group our variables together so that we can complete the square. And we can rewrite this as I'm going to subtract 4, so it's going to be negative 4 over here. Now we're going to factor out. We can factor a 4 out, and we can factor out a 9 here. So that's going to be a 4 and a 9. So x squared minus 4x, and we're going to leave a space there. And then here that's going to be plus 9, but we're going to have y squared plus 4y, and then a blank. It is equal to negative 4. So now we're going to have these values here. We're going to have negative 4 over 2 squared is equal to 4. And we have 4 over 2 squared is equal to 4. Now we add these back inside of the parentheses, and you're just going to balance the equations. So on the other side, you also have to add those values too. But remember, they're being multiplied by something, so you have to add that. You have to remember to multiply that too when you're adding it to the other side. So this is going to be a plus 4 times 4, and also a plus 4, or I mean a plus 9 times 4, because we had 4 to both sides. And this is equal to negative 4 plus 16 plus 36. That's equal to 48. Negative 4, that was. And now we factor the squares on this side. So that would be 4x minus 2 squared, and that would be 9y plus 2 squared is equal to 48. Now all you have to do is you have to put this into standard form. So the way you do that is you would divide both sides by 48, because you want this right-hand side, your right-hand side should equal to 1 so that we can see what a squared and b squared are. So after this, that's equal to 1, and this is going to be equal to 4 over 48. That's going to be 1 over 12. So you have x minus 2 squared over 12 plus 9 over 48. So that would be y plus 2 squared, and you could just flip that as a fraction in the denominator, so that'd be 48 over 9 is equal to 1. Now this is x minus 2 squared over 12 plus simplified y plus 2 squared. This could be 16 over 3 is equal to 1. Now, what type of conic is this? What we see is that this is going to be a ellipse because you have both terms are positive, and our center is going to be equal to 2, negative 2. Now, what about another problem like this? Let's say we have x squared minus 4y squared plus 2x plus 16y plus or minus 3 is equal to 0. So now you can group these variables together. That would be x squared plus 2x minus 4y squared minus 4y minus 3 is equal to 0. So x squared plus 2x minus 4y squared minus 4y is equal to 3. Just adding that 3 to both sides. So now after this, we're just going to complete the square. Let me make a little bit of room for that to do. So take this, you're going to take 2 over 2 squared is equal to 1, and negative 4 over 2 squared is equal to 4. So moving this over here, you're going to have x plus 1, and you're going to add these to both sides. So you're going to have a blank space here. Let's add to both sides. What color have we made this? We've made this usually I think so. We're going to add 1 here, and we're going to add a 4 here. So on this side, we're going to add a 1 and also subtract a 16 because it's going to be negative 4 over 4. That's just equal to 16. And let's just simplify after this. This is equal to negative 12. After this, we can factor. This is x plus 1 squared minus 4y minus 2 squared is equal to negative 12. Now after this, all you're going to do is just divide by negative 12 on both sides. So this is going to equal to y minus 2 squared over 3 minus x plus 1 squared divided by 12 is equal to 1. So we can see that we have one term is going to be positive, and we have one term that is negative. So that means that you have a hyperbola, and that's going to be at the center of negative 1, 2. Now let's do another problem. Let's say we have a like this y squared minus 8y minus 12x plus 4 is equal to 0. And we're going to first group our y terms. So we're going to have y squared minus 8y blank minus 12x plus 4 is equal to 0. And you're going to move your constant onto the other side. So what we can do is we have y squared minus 8y is equal to 12x minus 4. So you're going to complete the square here. So that's going to be negative 8 over 2 squared, and that's equal to 16. So you're going to add that in the absence location here. We're going to add a 16 here, and we're also going to add a 16 here. So this is going to simplify down to what this is factored, y minus 4 squared, and this is 12x plus 12. Now if you factor the right side, it's going to be 12x minus 1, or x plus 1, and this is y minus 4 squared is equal to this. So this matches the conic form, that is y minus k squared is equal to x minus h. And this is a parabola with a vertex of negative 1, 4. So, now let's go over what the general forms of all of the conic sections are again as a final review. So, in general, when you have a circle, that was when we had x minus h squared plus y minus k squared is equal to r squared. When you had an ellipse, that was when you had x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And then for our hyperbola, that's when you had x minus h squared over a squared minus y minus k squared over b squared is equal to 1. And now finally for our parabola, you had y minus k squared is equal to 4p x minus h. And this one has a variant of x minus h squared is equal to 4p y minus k. And that's because you have a vertical or a horizontal parabola. So I can also show you a trick on how to determine from looking at a general form of a conic quickly in 3 to 5 seconds without completing the square. So this is a speed trick. So when you have your general form that we've seen earlier, which is this form, when we have this form, we have to first check if there is going to be an xy term. So you're going to check for this presence. So that means if b is not equal to 0, that means your conic is rotated. However, most problems of this level don't include rotation. So usually your b is going to equal to 0. So now that's your first step. Your second step is you're going to compare x squared versus y squared. And we're going to make a table for this. So let's say that you have both squared terms present, same sign, same coefficient. That's going to be a conic, and it's going to be a circle. Now, what if you have both squared, so that's squared terms present, you have same sign, but you have different coefficient? That's going to be an ellipse. If you have square terms with opposite signs, that's going to be a hyperbola. And if you have only one square term, which makes sense, as you've seen in algebra, you have just a parabola. Now, we can go back to all of our problems and apply this rule and do this faster. So, for example, in question 1, we have x squared and y squared. So we have both of them are present. We have a same coefficient and your same sign. So that's how you know that it's going to be a circle without even doing anything. If you were to skip this, complete the square part, but there are questions you will have where you have to show your work and you have to show that you completed the square. So I recommend only using this method to check your answers if you're doing a multiple choice problem or true or false problem. But you should know how to complete the square. It's quite important. Now, for this example, we can look at our 4x squared and our 9y squared. So we can see that x and y, they're both present. you have different coefficient, and you have same sign, so that is going to be an ellipse. And as we did our work, we saw that it was an ellipse, so that matches. Now for this third question, we are going to look at our x squared and our negative 4y squared, and we can see that they have opposite signs, so that means that it's a hyperbola. And that's true because we completed the square and saw that. Now for the last one, we see that we only have one squared value, one squared variable only. So that's why it's a parabola. So the way you can simplify this table is like, if you see same, so same, that's gonna be a circle. Same, different, that's gonna be an ellipse. If you see opposite, that's gonna be hyperbola, and then you have one squared, that's gonna be a parabola.